Okay, let's go over it then. I'm going to focus as we go through it, not just on the right answer. Yes? The one in the back? Yeah, it's causing a glare. Sure. How's that? Better? Yeah. Feel free to move closer, too, if you need to. There's some empty spots up here. All right, so notice it says to show all work in the space provided. So just like a free response question, I'll try and give you enough space to do your work, but if you write large, then just do it on separate paper. Use proper notation when? When do we have to use proper notation? Always, okay? So even if it's a multiple choice on the worksheets, remember you're practicing your notation as well. Because if you never practice it, then you're not going to be able to pull it off. And show all of your steps always. Remember that on this section, the process is as important as your product. So I grade your process. It is the product to some extent. All right, so part A. You're given these four functions, actually, F, G, K, and P. And part A just says to set up the following function. So this is just as easy as pulling out the correct functions. All right, so G of X. Very, very, let's see, G of X is 21 plus 10x plus x squared all over f of x, which is negative 2x squared plus 2x plus 24. So it's that easy. Now notice on the notational things. Notice that I gave you h of x equals, right? And did you see what I did when I set it up? I kind of kept my equal signs lined up, and I put the equal sign, and I wrote my expression. What does that infer? That what I wrote is still equal to what? H of x. So if you have it like that, then go ahead and give yourself a check. That'll be the first check. If you do not have an equal sign, and you just have an expression floating around out there like that, you're going to lose that first check. So if you just have an expression floating around, and it's not equal to anything, you're going to lose a check. If the equal sign, oh yeah, if you actually put h of x equals, then of course you've locked in that first check. And that's the better thing to do, because then you don't have to really worry about your equal signs lining up. But you're setting up equations, you're not writing expressions. So without the equal signs, it's R-O-N-E-G wrong. Yes, sir? Oh, absolutely. Yeah. You could have it like that. And I remember many of y'all were asking in class if you could rewrite the order. And sure, x squared plus 10x plus 21 all over negative 2x squared plus 2x plus 24. So that works as well. But you got to have it equal to something, all right? Must be an equation for the first check. I'm just going to rewrite that. Okay? Any questions on the first one? If you factored it in this step or did anything like that, then you don't have to grade it on today's quiz. But if you ever do more stuff in one section than you're supposed to, it has to be right, or you can lose a check that you possibly already earned. Has to be an equation. All right, part B. Now it says to write h of x in factored form. Guess what we need again? We need h of x equals. Now I'm not going to take off a point again this time, but again, it should be an equation. If you hadn't written in descending order on part A, maybe now's the time you'd want to write it in descending order. The top then would factor, looks like, into, hopefully, right, x plus 3, x plus 7, or x plus 7, x plus 3. I'll give you a separate check for factoring that. Be nice. And the bottom, what's the first rule of factoring? Pull out a common factor. And I noticed a lot of people in class were not pulling out the negative 2 first. It makes it a lot more fun to factor. But again, limit yourself. Choose your fun carefully. So that's going to change all the signs. So if you do that, then I'm just going to rewrite the top. And again, notice how I did it. I worked straight down, but I have my equal sign correctly lined up, which means it's still equal to h of x. And now it's easier to factor this one. It's going to be x minus 4, x plus 3. And I'm going to give that as the third check. Now, I noticed that some people left the negative 2 in there. So if you still have like a negative 2x plus 8 as one of your factors, or you have a negative 2x minus 6 as one of your factors, then go ahead and give yourself the third check as well. Because I didn't say to factor it in its prime factorization, and technically you have it factored. But in general, you want to factor it always to its prime factorization. And when do you pull out common factors? At the very, very end or first? First, never not first, right? It makes it easy. Okay, so let's go ahead and say you can have a negative 2x plus 8 or a negative 2x minus 6 is okay for the third check. But it's not completely factored, just to be aware of that. All right, and then it says to find the domain. You might want to come back here. Hang on, I'll put h of x equals. Find the domain. And so now it's real easy, right? You just look at the line above. And x minus 4x plus 3. I know that the domain of h is going to be the set of all x, such that x is not equal to 4 or negative 3. And I'm just going to do that whole thing as one check, with the notation and everything. Or you could say the domain of h is going to be from negative infinity to negative 3, union negative 3 to 4, union 4 to infinity. Either one of those. Now, if anyone up here on the previous one divided out your x plus 3s, that's not really the time to do that, okay? So for now, if you have the original thing factored, but you divided out your x plus 3s and you have x plus 7 over negative 2x minus 4, give yourself the third check. But in this case, I didn't ask you to simplify. I just said write it in factored form. So that would be the time where I'd want to see everything that is a factor present in your final answer, okay? So far, so good? We're going to tie the notation to the right answer on part C. Now, the only thing that you could be missing from the notation is technically the subscript. If you just want to put big D, it's okay, it's domain, but if the function has a specific name like H, F, or G, you just also want to get in the habit of putting the subscript because it's more information. And the better you can communicate your results, the better off you're going to be. You're leaving less to chance. All right, find the equation of any vertical asymptote. Well, here's where you could just look up here to the factored version, and of the two discontinuities, x minus 4 does not divide out, does it? So it's your non-removable factor, therefore it's going to be your non-removable infinite discontinuity. The x plus 3 factor does divide out, so it is a removable factor, and therefore negative 3 is going to be your removable point discontinuity. You don't even have to show the dividing out there. So we're going to have a vertical asymptote at, now because I just asked you for the vertical asymptote equation in part D, all you have to do is put x equals what? Negative or positive 4? Yeah, and that's it. Now you could, of course, say VA at, but VA at is going to be a little bit more important if I had just asked you find the equation of any asymptote. Now it's important to say what type it is, right? Find the equation of any asymptote. Oh, there's a vertical asymptote here. But on this problem, the only thing I'm saying is what's the vertical asymptote's equation, and there's the equation. So this right here, VA at, would be optional in this case. What if you put just 4? Wrong. What if you put y equals 4? Wrong. What if you put x equals negative 3? Wrong. Also, it has to be x equals 4. All right, A, B, C, D, I guess E comes next. Find the equation of any horizontal asymptote. Now, let me add something here. Show if I added this on the test, I didn't ask it here, show your analysis. That's kind of an important little thing to add because that requires a little bit more notation on your part. But I didn't ask that here, so you don't have to show this. But here's what I mean. Show your analysis means what? How do we find horizontal asymptotes? The what? The end behavior. Well, yeah, the end behavior model. But what are we looking at? We're looking at the. But we're evaluating a what? Limit, right? Remember the definition of a horizontal asymptote? So it does come down to the end behavior model, yes. So you could say the limit as x goes to infinity of h of x equals. Now, if you want to put h of x there, you can. If you want to put what the actual h of x expression is, you can. But that would be the analysis. That's all I would need. Now, the best version to come back to for the end behavior model is not the factored version, is it? But rather the expanded version. And if you wrote it in descending order, then your leading term should be in front. So we have an x squared over x squared. So if you got rid of all the other terms, what would the end behavior model be? It would be negative 1/2, which is a horizontal line, right? And the end behavior on any horizontal line is just that y value itself. So you could say negative 1/2, or you could say, when the degrees are the same, x squared over x squared, then it's just leading coefficient over leading coefficient. So whatever it is, it's negative 1/2. Now with the analysis, the limit is negative 1/2. And if you did the other end, the limit as x goes to negative infinity of h of x, that would also equal negative 1/2. So because the limit equals negative 1/2, we know that there is a horizontal asymptote. So h of x has a horizontal asymptote at y equals negative 1/2. Now, what are you going to have to show on today's quiz to get full credit? Well, just this. Just this. Because I didn't ask you to show the analysis. Had I asked you to show the analysis, then you would need everything that's there. Let me go ahead and just clean this up so I can post it. All right, what if you just put negative 1/2? That is wrong, right? There's a reason equation is in bold there. What if you put x equals? That is wrong. Yeah, you need y equals. So we're going to tie that to the right answer. All right, any questions so far? This is all just kind of nicely laid out in sequence to help you answer things in the right order, or makes it easy to answer based on what I had you do in the beginning. Yes, similar too. And again, I would look at the release tests from previous years to kind of start your. If you think you're ready, then maybe sit down, give yourself 50 minutes, and try one of those release tests, and then grade it. You have the key there, so you can grade it and see how you do. And that's a good thing to do when you think that you're ready for the test. Because remember, if you never sit down and try and do something in 50 minutes on your own, then you're not really ready for the test. Because that's what I'm expecting you to do when you get to class. And you don't want that to be your dress rehearsal and your show to begin with, or all at the same time. All right, part F, find the y-intercept of h of x, listed as an ordered pair. Now again, you should always get in the habit of show the work that leads to your answer. That might be what I would say here on the test. Show the work that leads to your answer. So sometimes we add these little things on the end just to kind of communicate to you that, hey, a bald answer is what we call it. A bald answer just means the number is just appearing out of nowhere and you're not communicating how you're getting it. A bald answer would not be enough. Okay, but in this case, I didn't say it. So how would you show the work that leads to your answer? How do you find y-intercepts of any function? You set x equal to 0. Now, because it's a function, the easiest way to do that is to put h of 0. And that would be all you need to show. That would be the work that leads to your answer. Now, for h equaling 0 or x equaling 0 into h, again, it's probably easier to come up here to the expanded version because everything that has an x in it is going to become 0. So you get 21/24. So 21/24. Or, of course, that simplifies down to what? 7/8. Now, to list it as an ordered pair, here's what you have to have. Either 0, 21/24, because I didn't tell you to simplify, although you should always get in the habit of doing that, or 0, 7/8. I'll accept either one of those as the right answer. Oh, sure, yeah, you could do that. Y-intercept at, and again, the more you write, the more you communicate, the better. So that would be great. But in this case, because, again, this particular set problem right here only asks for the y-intercept, if you just list an ordered pair, there's no ambiguity as to which it is. Now, if the instructions had just said to find all the intercepts of the function, there are two types of intercepts, right? X and y. So then it's more important to label it. I have a y-intercept here, and I have an x-intercept here, all right? But if you just want to develop good habits and always label things and write in complete sentences, that's good. Always show your mathematical intent. H of 0 equals, perfect. All right, part G. Find the coordinate xy of any removable point discontinuity. So now's the time where you might want to come back over here and divide out your x plus 3's. But you don't even have to show that if you don't want to. But I'll go ahead and just copy this and paste it in over here. I know some of y'all probably went ahead and wrote that in there. And I understand why. It's kind of fun to divide things out. Right? You divide those out. So then you could say that there's a hole at, and again, that's not required here because the instructions are specifically saying that, at -3, comma, and I'm going to go ahead and give a check for the x coordinate by itself, just like I did on previous tests. So if you just said hole at x equals -3, you're going to get 1 check. But how do we find the y value of the hole? Plug it back into what remains, all right? So if you plug in a -3, you get 7 minus 3, which is 4. Over -3 minus 4 is -7 times -2 is 14. So you could leave it like that. Or -3, comma, that simplifies to 2/7. So then either one of these could be the 9th check. But it has to be written as an ordered pair. Okay, so of the 2 checks, the 8th and 9th check, we'll just put must be an ordered pair. If not, lose 1 check of the 2. If not, but you have the right numbers, lose 1 of the 2 checks. And it doesn't matter which one. Now, here's a follow-up question. What would be the limit as x goes to -3 of h of x? Yeah, good. It's 2/7, right? I could ask that question instead of asking you for the coordinate of the hole, because it's the exact same question. So like on the test, I could just say, what's the limit as x goes to -3? And you'd be like, oh, that's where we have a hole. So I know that the limit is going to exist because it's approaching the same thing from both the left and right, and it's just the y value of the hole. So how do I find the y value of the hole? Yeah, same thing we just did. So really the same type of question. What would be the limit as x approaches -3 just from the left side? 2/7, right? Yeah, it's going to be the same thing. Because remember, the general limit is going to exist at a hole, which means the limit from the left and right are the same thing. Okay, so that was the 8th and 9th check. If I had asked it like this, then that would just be 1 check on the test versus having you tell me there's a hole there, which is maybe 1 less check. All right, part H, find the x-intercept of h of x, listed as an ordered pair. Well, how do we find x-intercepts? Yes. I might say something like show the work that leads to your answer on the test again. And so if I did that, you would have to first show me this, h of x equals 0. That would earn a check right there on the test, because an x-intercept is the same thing as a 0, as a root, and it's a solution to the equation h of x equals 0. They are all the exact same thing. So let me go ahead and write that out here like we had on the quiz. A 0 is the same thing as a root, which is the same thing as an x-intercept, which is the same thing as a solution to the function h of x equals 0. They are all mathematical synonyms. Okay? Now, when is a function equal to 0? And when it's a ratio? It's when the numerator is equal to 0, right? So let me go ahead and paste this again down here, just so I don't have to rewrite it. So you might want to actually bring h of x equal to 0, something like that. Now here's where you'd have to be careful. I wrote this up on the board. It was in your notes as well. 0 over 0 means whole. Non-zero over 0 means vertical asymptote. 0 over non-zero means 0, x-intercept or root. So here's where you'd have to be careful. It comes down to the ratio is going to equal to 0 when the numerator is equal to 0. But you have to be careful, as I already mentioned, because you have two different factors in the top that cause a 0. Are both of them going to be zeros or roots? Are we going to have a root at -3 and at -7? No, why not? Yeah, x equals -3 as a whole. So the way that you find the x-intercepts is after you find a whole, you get rid of that factor. And for the rest of the entire problem, for all that remains, for everything else, you can just use what's left. In other words, the questions that we've been answering, I could have been using this instead of referring back to the original, right? Let's see what the x-intercept of this is, or the y-intercept. If you plug in a 0 right here for x, you get 7 over 14, right? No, 7 over 8. You get the exact same thing. What would the limit be as x goes to infinity here? Well, it's 1x to the first, right, over -2x to the first. Same degree, it's 1 over -2. So again, once you find a whole, if you want, you can divide it out and then use what's left for the rest of the problem. Makes it a little bit easier. So now, the only thing that's left to do is show that you're setting the numerator equal to 0. And we talked about that in class. You do not want to multiply both sides by the denominator. 0 times anything is 0, but you don't want to multiply both sides by the denominator. Instead, you get to that same line by saying, a fraction is equal to 0 when just the numerator is equal to 0. So it ends up being kind of the same thing, but it's for a very different reason. So now x equals -7. Now, do you have to show all that on this quiz? No, because I did not say to show the work that leads to your answer. But if I did, you would need all of that right there. So here's all you need, because you could have just looked at it and said, the only value of x that makes the numerator 0 after the whole is gone is -7. So the x-intercept, and again, you could say x-intercept at, but here's all you have to show, -7, 0. That is it. That's your 10th check. No, you could write the word at. On the quiz, you mean? No. On the quiz, all you have to put is -7, And again, because this question is asking you to find the x-intercept. Oh, that's fine. Did you put a colon or anything? Well, I should put a colon or something. Yes?
Do we get it wrong if we put -30?
Yes. If you put, yes, good. If you put -30 and -70, you're just going to lose one check. You won't get any check there. Yes. Is that what you did, Phipps? Yep. Yeah. Let me make a note of that. You're going to lose a check if you list both -30 and -70. And the reason being is because -30 is not, first of all, not a point on the graph. We said right above there that it's -3/2/7, which is not on the x-axis to begin with. And the second thing is it's not on, well, it's not even on the graph at all. There's a hole there. So that's why those are asked back to back. So you do have to think all the way through these problems, right? And as I mentioned at the beginning of the year, what's the whole purpose of math education? Is it so that when you interview for a job somewhere down the road after you graduate from college and the interviewee asks you to fill out this for your job, you can make 100 on it and get the job? That's never going to happen, right? No, it's just so that you go what? You could think, well, that'd be a great interview though, right? You're applying for like a sales associate or something, like at some retail store, and then you have to do this. It's like, wow. Yeah, no thanks. It's not going to happen. But the thinking part will stay with you. All right, so the first one is worth 10 checks. How are we doing on time? I don't have my watch today. We have 10 minutes. Okay. Number 2. It's not even listed as number 2. Well, oh well, let's just call it number 2. We got f, g, k, and p. Set up the following function. So once again, kind of the same idea. We got k of x equals -5x to the 6th minus 3x cubed plus x squared minus 12 all over p of x, which is -2x to the 5th, -2x to the 5th, plus 8x to the 4th, minus 5. So that's going to be the 11th check. But again, it must be an equation. It must be an equation. And we're going to start increasing the penalty for having the wrong notation. Instead of like 1 each time and being inoculated against any further deductions, you're going to have it each time, or you're going to lose a point each time. So again, the way you do it is like we did up on the previous part A. You work straight down from the equal sign without the Q of X, or you just have Q of X equals because you don't want to take any chances. Okay, but it must be an equation. Letter B, find the equation of any horizontal asymptote of Q of X. I didn't say to show any analysis, but if I said to on the test, what would you show again? How do we find horizontal asymptotes? One more time. The limit. You find the limit as x goes to infinity of Q of X, and you find the limit as x goes to negative infinity of Q of X. I didn't ask you to show that here, so you don't have to show that, but let's see. We look for the leading terms, and they're both in front, correct? So because 6 is bigger than 5, this is going to go to some type of infinity. The top grows bigger faster. So this is infinity, and that's infinity. Now, I think we're kind of answering 2 of the other questions right here, yeah? But that's okay. This is part of the analysis for horizontal asymptote. Let's hold off on that. Let's hold off on that. I'm gonna hold off on that. Because here's another way you could do it. If I just ask for the horizontal asymptote, remember we get a horizontal asymptote in 2 of the 3 situations. When the bottom is a larger degree, there's always a horizontal asymptote at 0. When they're the same degree, like we saw in the previous problem, it's always leading coefficient over leading coefficient. But if the top is larger by any amount, there is no horizontal asymptote. So find the equation of the horizontal asymptote. You could put none. That would work. And that would be check number 12. Check number 12, none. Did anybody put something else besides none? Like, yes, Q of X does not have any HAs, or ain't no thing. Anyone put ain't no thing? What's that?
I put Q has no HA.
Ooh, I like that. Q has no HAs. That's answering in the affirmative negatorily, right? Like, yes. Like, do you have any bananas? Yes, we have no bananas. Have you no bananas? Yes, I have no bananas. I like it.
What about no HA?
Oh, okay, I'll take that. As long as it's negative. As long as you didn't try to answer it like at y equals 5. Okay, something that's framed in the negative should be fine. All right, ABC comes next. Find the y-intercept listed as an ordered pair. I'm not going to keep writing the instructions to show the work that leads to your answer or show your analysis. What should we get in the habit of writing though each and every time? How do we find y-intercepts of any function? Q of 0. Q of 0. Good. Now when you come back up here, it's easy in expanded form because it's just constant over constant. So negative 12, negative fifths. Negative 12, negative fifths, which of course simplifies to positive 12 fifths. Or 2.4 if anyone wrote that. So it says to list as an ordered pair. So again, y-intercept at, I'll write the word at this time, 0, 12 fifths is probably the best answer. And that'll be the 13th check. But what do you have to show? Just the ordered pair here. But you should get in the habit, again, of writing everything I have here, even if it doesn't ask for it. All right. We have like 5 minutes. The limit as x goes to infinity. Well, we know that since the top is a larger degree, the answer to both of these is going to be some type of infinity. Yes? Some type of infinity. All right, so I'm going to give you, let's see, that's the 13th check. I'm going to give you the 14th check for putting any type of infinity. Any type of infinity. And then how do we figure out the sign? You plug it back in to the leading terms, right? So looking at the leading terms, when you plug in a positive value for x to the 6 is going to be positive times negative 5 makes it negative. And same thing in the bottom, you're going to have a negative. So what's a negative over a negative? Positive, okay? So the 15th check will be for positive or just infinity, okay? And that's going to be for the sign of infinity for the 15th check. Of course, you don't have to put a plus in front. But if you just have infinity, then you get 2 checks. What a great deal. Same thing down here. Check number 16. Is this going to be for any type of infinity? Any type of infinity? Unless you wrote the number 8. If you wrote the number 8, that's like an infinity that's already out of bed and walking around. You don't want to do that. Okay? Yeah. So how do we figure out if it's positive or negative? Well, we're going to negative infinity. So we'll come over here. And into the leading terms only, we'll plug in a negative number. Now, on the top, a negative to the 6th power becomes what? Positive times a negative coefficient makes the top negative. And at the bottom, a negative to the 5th remains negative times the negative makes it positive. So a negative over a positive is a negative. So then the negative sign, which is now required, is your 17th check for the sign. Now, that's one way to do it. You could have done the end behavior model. Tyler Allman, what is the end behavior model? Well, if you just simplified the leading terms, you would get 5 halves x. Yeah. You would just get 5 halves x, which, of course, is a line that looks like that. And so now it's going to be to infinity as you go out to the right, and it's going to be to negative infinity as you go out to the left. So that's another way you could have gotten the signs if you look at the end behavior model. And I don't care how you do it. So there's 17 checks. 17 checks. Let's do 4 points each. That's not quite full price. I think that'll work great. So I think we went through how to grade it pretty extensively, focusing on the notation. Make sure your name is on it if it's not already. Pass it to the front of your column. I will get these back to you tomorrow, so you leadership people, if you want to swing by before you leave or when you get back, I can hand it back to you and give you your homework as well so you can use it. So tomorrow we're going to do some PSAT for about 25 minutes, and then come with questions, and I'll answer your questions about the test, and then the last part of class we'll talk about what the test looks like. I would look at anything that's through 2.3. Remember, your test on Wednesday is comprehensive, so anything that's a release test that goes from 1.1 up to 2.3 is going to be good. Okay, but it's going to be heavier on Chapter 2, so anything that's 2.1 to 2.3. If blue skidoos, we can too.